Hello, everybody. Please grab a seat. As you might notice in the agenda, that's a workshop tutorial. So if you want really hands-on experience, get your laptops out. So we're going to try to keep it as much informal as we can, whereas quite a few of us, so once we end up with our part on a stage, we're going to start mingling around. So if you have a question or something is broken, ask a hand. I'm very cautious. There is 500 of you and 5 of us. This means everybody of us gets 100. So please help your table friends, co-workers, colleagues, if you can. So that's, and we have a few other KCP friends and family. So if you have a question during the silent time and we're catching up, there's a microphone in the center. Just grab it, ask it. So let's not wait for the Q&A at the end.
There is no microphone, actually.
That's one in the center.
There is?
Yeah. Cool. So we're good to start. So welcome to exploring multi-tenant Kubernetes APIs and controllers with KCP. The link will be always in the footnote of the slides. This is where we'll be hanging out. But before that, a bit of intro. So prerequisites, we will require 4 shell terminals, Linux MacBooks. We strongly recommend using GitHub code spaces. We're going to show how to set it up. Hence, everybody has the same environment and we can debug faster. But if you feel comfortable, use whatever terminal you like. And for the starters, Git is basically what we need, and we're setting up everything else. A bit of intros. I'm MJ. I'm staff engineer at Cast.ai and KCP maintainer. So been with KCP for the last 4 or 5 years.
Hello, I'm Robert. I'm working for Clyso, a company that's primarily focused on storage, software-defined storage and Kubernetes. But recently we started investing time into KCP as well. And I've started on the project not too long ago, about 4 or 5 months. But still learning. We are even today learning together, and let's see.
Hello, everyone. I am Marko Mudrinic. I am a senior software engineer at Kubermatic, and as of recently a KCP contributor. Very happy to be with you all here today and to learn a bit more of KCP as well.
Hi, everyone. I'm Nabarun. I have been contributing to Kubernetes for the last 6 years. I maintain a few areas in the project. Currently, I'm also a chair of SIG Contribex, and apart from that, I contribute to KCP and try to build products around it. And that's all.
Hey everyone, I'm Varsha. I work as a software engineer at Red Hat. I'm in and around the Kubernetes ecosystem with operators and things. And I was a part of the KCP team when it was first introduced and designed. So, yep, that's it for me.
Cool. So high-level plan for today is we're going to set up environment and a few other utilities, explore the concepts live, because mainly this workshop is because we got a feedback from the previous talks that on slides it looks fine, it's good, it's needed, we don't know how to use it. We don't understand how it's wired up together. So this is why we're here, basically, to get our hands dirty. And we're going to lift and shift existing Postgres operator, CNCF Postgres operator, to convert it to database as a service. It's not a production code, it's more like a showcase how to do that. If you as a platform team building something that. And we introduce a bit of a new kid on a block, multi-cluster controller runtime. I will give a reference next to the other talks, which is about that, but you will get a sneak peek here too. And again, ask questions at any time. How it's going to be done, so we have a 75 minutes. If you run through the scripts, you can bash out everything in 5 minutes, get something running, and leave. That doesn't mean you're going to learn something. So feel free to stop at these pauses, explore, try the concepts, and understand what you're doing. Hence all the time we have. But again, that depends on everybody's pace. And a content warning, it's a deep technical content, we are here to participate. We are not here to sell it. You might think like we are very diverse companies said. It's not a market pitch. So it's all about hardcore tech stuff, like in old days. So brace yourself. So before we jump into the tutorial material itself, what is KCP as a reminder? You might have seen it already in a keynote today. It's a Kubernetes-like control planes. KCP is not Kubernetes. It loves Kubernetes. It uses Kubernetes-style APIs, but it's not Kubernetes. It's took a few terms from other pages. It's open source, horizontally scalable control plane. So every cloud provider has its own control planes, either it's Azure, Google, or AWS. This is an open source version of control plane where you can build your own APIs and lifecycle them. So that's a high level, and you might get more grasp what it is once you start doing this stuff. And for those who are familiar with KCP, and I needed to ask that in the beginning, can you raise a hand who knows KCP or used KCP before? So quite a few, but not much. So in KCP, we have this concept of workspace. Workspace can be put into the hierarchical structure like folders. Every workspace is like a virtual Kubernetes cluster. So at the end of the workshop tutorial, you would have to have something like this on your own laptops. And we have part 1, 2, and 3, where we've been doing consumers, producers, providers, basically. And yeah, let's see how it goes. A bit more high level, we're going to be setting up these components, which we call sync agent, and we talk about that as we go, controller runtime, and this is just to show which parts comes in which part of the workshop. And I think with this, if there is, maybe let's start clicking keyboards and see where it takes us. And again, questions anytime, raise your hands. We're around here, quite a few of us, so let's see. Nabarun?
Do you all want to shard around now? You all want to shard around the tutorial room? Like you want to spread around?
Yeah.
Awesome.
So Nabarun takes over part 1, and I will be just hanging out around to ask your questions and help you if you need to.
Awesome. So how many of you are here with a laptop or some device where you can run a browser? Okay, quite a lot. So we would at least need a browser for you to run GitHub code spaces. And now I'll show you how do you create a code space and then set up the prerequisites and then install KCP and run KCP so that we can move on to the next steps. Awesome. So the repo, 1 minute before that. Have you all scanned the QR code and opened the documentation? Can I have a quick raise of hands? Awesome, and how many are left or still doing it? Okay, quite a few. Let's give it like 1 or 2 minutes. So all of the workshop steps are structured into a documentation repo where in the contrib repo essentially where you can go and see everything step by step. We will in turn take you through all the sections and then go over them. So it's important for you to open this website on your devices. Okay, I'll move on, but in case if you want help with the QR code, we are all roaming around. So do let us know, raise your hand if you want any help and we'll reach out to you. Cool. So in order to get to GitHub code space, all you can do is on your browser, type in github.dev, which is important, not github.com, github.dev/kcp-dev/contrib, which will essentially open a VS Code-like interface, but on your browser. And you see we have the repo cloned here. So let's go over how do we create now some terminals on code spaces. If you click here and type the closing angular, closing triangle brackets, and type in terminal, either you can do like toggle terminal or focus on terminal view. Either will, depending on what the state of the code space is in. You just focus there, and then you can click on continue working in GitHub code spaces. For the purpose of this workshop, whatever you get as part of the github.com free account should be sufficient. We will create like an 4-core 16 GB RAM machine. For whoever is on the github.com free tier, they will get 2 options of 2 cores and 4 cores. Both are sufficient, but you can try using the higher core one. And you essentially, as part of GitHub's free plan, get 120 core hours. Should be good enough for today. So here we are. So we have a terminal with us. So let's try to go over the steps one by one. Cool. So as part of the prerequisites, so I showed you how to use GitHub code spaces, but if you are running locally, you need to clone the repo first. So once you clone the repo, who are on local terminal? Can I have quick show of hands? Because the local terminal way would be a little bit slower since we are on conference internet. If you're on code spaces, you are essentially running everything on cloud. Should be a little faster. So for those who are using things locally, you can do git clone. Basically, you can go to this page, the 00 prerequisites, on the website that you opened the QR code from. Clone the repo, go into the contrib repos workshop directory, and from there we can restart. For those of you who are on code spaces, you don't need to git clone it, since the code space already has the repository for you. Okay, giving 1 more minute so that people can at least start cloning the repo, whoever is doing it locally. Okay, so let me go through the GitHub code space way of doing things. So I'm essentially in the contrib repo. I go into the one quick check. Is the font size visible to you all? Bigger? Little better? People on the back, can they see the screen now? Awesome, thank you. So essentially, I go into the workshop directory. So most of the times when we open a new terminal, we'll ask you to open a few terminals over the course of the workshop. The basic thing is like you cd, like change directory into the workshop so that you can proceed from there. So now let us set up our environments. We've made it a little easy for you to install everything. We have built some scripts. So what you can do right now is run this script, 00-prerequisites/01-install.sh. Again, these are all on the website. Whatever I am saying, you don't need to just listen and copy, but then you can go into the website, do copy paste from there, and then run it on your environment. So let's run this. So we download KCP. We download this thing called API Sync Agent. We download, what do we download? We download an example multi-cluster runtime provider that we created for you to test in this workshop. We download kind so that we can run a cluster where the actual workloads are running. We install kubectl. Obviously, this environment has nothing, so we need to make sure we can interact with the control plane. And we install crew to manage some of our kubectl plugins. So how many of you are till here? I know we're going a little fast, but just a quick check. Oh, awesome. I'll probably give a minute for everyone to just run the script on their environment.
It's like, you can go ahead if you want and be a bit ahead. So if you have questions for the further parts, just ask questions too.
How many of you are through the first one now? Like a quick raise of hands. Okay, quite a few people. So I know internet might be a little issue with this step and the third one that we will do. Other than that, it should be fine with what internet we have here. Okay, so let's go on to the next one. So after doing each step, we have created a script which will check your environment whether you are ready to go to the next exercise or not. So whenever you are in any of the exercise, what you can do is, for example, I'm in 00, I run this 99-hi5.sh script and check whether I'm good or not. And it seems we're good right now. So if you run that script and it shows all green, you're good to go to the next one. So let's move on to the next one right now. Now we come to KCP. So in order to not confuse too much like KCP with Kubernetes and how Kubernetes works, how you can understand KCP is it's just a single binary process, can be run in any form or fashion. It can be deployed as a Helm chart. It can be deployed through our KCP operator, which is our suggested way for you to run if you're running it in production. But for all purposes in this workshop, we're going to run KCP as a binary to keep it really simple and running it on your machine itself or your environment. So let's go on. You need to make sure you have a few environment variables. Oops. And how do you start KCP? It's very simple. Once you install KCP, you just do KCP start, and it starts the control plane for you. Let's see what it does when I do that. So if you know how Kubernetes API server starts, it's very similar to what happens when you start Kubernetes API server, plus a few additional controllers to make sure certain things are running well in the control plane. So in a way, it's Kubernetes as API server plus controller manager merged together and stripping out a lot of things. So when you do KCP start, it runs the whole KCP control plane plus the controllers which make sure any processes inside KCP run well. So I'll just wait for some time, and in the meanwhile, I'll create a new terminal. So in code space, you can just go over to the top right and click on the plus icon, and you get a new session. Over there, I need to again export a few environment variables, and before that, very important, I need to go into the workshop directory. And then plain simple kubectl. Let's do, and I like to alias kubectl to k so that it's easy for me. So you can just do k version. And you see we have a server version here, which is the Kubernetes version that is backing KCP plus the KCP version itself, shown as server version in the kubectl version info. Having said that, if you are able to reach here, that's a great start. We have overcome all the internet hurdles for now. And again, to check whether you have created everything correctly or not, you can run the high-five script. But before that, before we move on to the next one, we will deal with a lot of kube configs. One would be the kube config to the control plane itself, the kube config to the service cluster that we will have running, the kind cluster that we will have, and a few others. So we'll just quickly create a directory so that we have all the kube configs stored there. Let's run the high-five script. KCP is reachable. So how many of you are till here? Okay. And how many are facing any issues so that we can help you? 3%. Okay, I'll be coming. Let's wait for a couple of minutes. By now, we are at the second stage of the workshop. Varsha? Varsha? We'll go and help her. So you can continue. So until here, and then KCP is running in this, the bash here.
So here we are. We have started our KCP server. And I know you are all here in the workshop because KCP promised two things. One is multi-cluster capabilities, and the second one is the whole promise of scalability. So we are going to get our hands dirty and go into the multi-cluster part of KCP and understand how things work.
Count from 0.
So let me go back to the tutorial.
We somehow.
And we'll explore the concept of workspaces. So before I get into creating workspaces, let me give a very brief overview about what workspaces are. So workspaces are KCP's unit of tenancy, and they, in other words, create a very simple stripped down API server with very minimal APIs which are provided. So for a user, that is the endpoint through which you will talk to your cluster. So all workspaces are backed by logical clusters, and for any clients, whether it's a controller runtime client or a kubectl client or anything, which needs to talk to a particular workspace, there is a specified URL and a way to reach the URL. And we'll go into detail on how the URL is structured and how a client can talk to a workspace and explore more about workspaces in a bit. So before we get into creating workspaces, let's do a little bit of prerequisite stuff, which is basically setting up the workshop root and crew root. So crew is kubectl plugin manager, and we have created a few plugins for KCP kubectl. So we'll be setting up those. And then when the KCP was started previously, if you could see in a .kcp folder, you would have a kube config in here, which is the admin kube config. So this is the kube config that we would be using for now to talk to our KCP cluster and create workspaces and things like that. So that's all what this bit is about, where we are setting the env vars.
So just run, in the workshop directory, just run .00, don't go there, run from there.
Okay. So let's just quickly check
Just hit it.
if we have our kube config set.
See, it always checks if the binary is present. But like, it will install it in a local directory. It will not override your installations. So it will use local setup.
Yep, and we go and
But
check our API
might be
resources.
that because we install everything to local bin. After that, you can drag
Okay,
it from the
there we go. And here we can see we have a workspace API available. So the next thing is going and creating workspaces so that we can talk to a workspace and understand more about it. So the next step which we'll do is add our KCP dev CLI through the crew and enable our kubectl plugins. So let's do the next step, which is basically copying all these stuff, downloading the necessary plugin, and setting up to be able to talk with our workspace.
You need to now set the environment path. You see, the workspace root is the one where we mostly do things. So that should be from the documentation.
Let's see. So one thing to make sure here is sometimes your kubectl create workspace may not work. So this is kind of a bug in crew plugin. So make sure to copy your kubectl create workspace path to your crew root.
No, like if you have it running, just run in the different terminal.
And let's see now.
Yeah, because 99 will always check it's there.
Okay. Still doesn't work. Let's try once again. Yep, there we go. So are we till here because there was a glitch in here? When you do a kubectl create workspace help, are you able to get this kind of output where it tells you that this particular command helps you create a workspace? Are we all good? Okay. Now let's move on to the next part where we start creating workspaces to understand more about it. Now let's create workspace 1. This, make sure to type out workspace because WR sometimes doesn't work. And let's create another workspace 2 to make things complicated and see how things work out. And let's go and see how the workspace structure looks like. So this is our root workspace, which is the parent. In other terms, it's very similar to our home directory. And then we have workspace 1 and 2. Now, if we get into workspace 1, you can see there are no CRDs in here. So this is a separate view of your own cluster. So in other terms, workspace is going to be your own cluster, which you can talk to and which you can interact to. So let's also see the API resources which are available here. And these are the APIs which belong to this particular workspace. And workspaces are isolated, which means the objects which you create in workspace are not visible on other workspaces which are provided to you. The other thing is workspaces help you create a hierarchical structure, which means, let me create another workspace, 3, and let me enter the workspace. So let's see what workspace is this. This is 3 workspace. And let me also create another workspace and enter into this. So right now we are in the workspace named potato. It's under root 1, 3 potato. So let me go back to root and see how the structure looks like. There we go. So this is the hierarchical structure which I was talking about that is supported by KCP, where you have a parent and your parent can have children or grandchildren. So let's dig into this a little bit more by creating specific API resources and see how things work out and how one workspace is isolated from another. But are we good till now, and do we get an understanding of the workspace? Like, any questions? Are you all able to create workspaces? Okay, thanks. Let's move on to the next part, where we show you how there's isolation achieved in a workspace. So what this part does is, I get into workspace number 1, I create a config map, and I see that how this config map is visible or not from outside the workspace. So let me do this. Let me go back to root. From root, every time I go back to root, I make sure to do a tree just to understand where I am and how things work out. Let me go back to workspace number 1. I'm in root 1. And let me go ahead and create a config map. So we have the config map here, which we have created in a workspace. It's very similar. It's the same as how it would be when you create it against a normal Kubernetes cluster. There's nothing different. Everything is the same. You have the object in there. Now, let me go to workspace 2. I'll go back to root first. Again, do a tree to just give you an idea of where we are. And now I'll go back to workspace 2. This is a separate cluster. And let me get the config maps in here. Boom. I don't see the config map which I created in workspace number 1. So this is the level of isolation which a workspace provides. So it's a separate API server. It's your own cluster. You can talk to it, and the workspace owner can create whatever objects that are relevant to them in that particular workspace. So just for the fun of it, let me also create a config map in here and see how things work out. And let's also create the config map with the same name. Because if you would remember, in a normal kube cluster, if you create any object with same names, those are actually, that's something which is not possible. The server rejects saying that you are creating an object with the same name. But just to show you the whole isolation part of it, let me go ahead and create another config map with the exact same name as we created previously. There we go. No errors, we are all there, and that's it. So this was about 2 different workspaces. We created config maps, the same exact config maps in 2 different workspaces. We saw that that was possible, and we also saw that whatever objects we created in workspace 1 were not visible in workspace 2. So are we good with that understanding? And shall we proceed to the next step? Are we all good? Okay, cool. So the next thing is the obvious one, where say I have a workspace, I have created a particular API, say a Postgres database, and I want someone in my organization to use the API which I have created. So how do we go about sharing the APIs which we have created? Now this is where in KCP, we bring in the concept of API exports and API bindings. So we'll go into that a little bit more. So please do follow the next steps. Let's go back to using our root workspace. And let's create a workspace named provider. Inside the workspace provider, I'm also going to create a separate workspace called Cowboy. Cowboy is the API which I'm going to create as a provider and share it to multiple consumers. So let's go create another workspace called Cowboys. And just for better understanding, let me again go to the root and show you how this looks like. So we have root, we have a provider's workspace, and we have a Cowboy's workspace where I'm going to create a Cowboy API. Now let me go into the workspace and see what we can do. So I'm going into root, then I'm going into providers, and then I'm going to Cowboys. There we go. Just to make sure, since we are going to switch workspaces around, whenever you switch a workspace, just make sure to check which workspaces you are in right now. So I am in the Cowboys workspace. The next thing which I would like to do is to create a custom API, which is known as Cowboy. Now to do that, we use the concept of API resource schemas. And let's see what API resource schemas are. So if you see here, the API resource schema structure looks very similar to how a CRD would look like. So we have all the details in here. It is a namespace scoped. It can also be cluster scoped. And the other aspect of an API resource schema is it is completely immutable. And that's the speciality of KCP, which helps in an API evolution. So once this particular API resource schema is created, at this instant in time, you cannot change the spec which is present in the resource schema. So let's go and create this API resource schema.
You went ahead a bit, so now this virtual URL aggregates everything. Yeah, that's it.
And see what this is about. Okay, describe API resource schema today.cowboys. Okay. This is fun, mistyping in front of so many people. There we go. So we have a Cowboy API. It is the same as we saw in our YAML. It is going to be namespace code, XYZ, and if we see the resources, we have the Cowboy resource somewhere in here. Okay, before going into the API resources, let me show you how do I expose this particular Cowboy API to other workspaces. So this is where we bring in the concept of API export. So the next thing which we would do is export this particular Cowboy API to other workspaces by creating an API export. So what this API export has is it has a spec which specifies the exact resource schema which I'm going to export, in other terms which I'm going to let the other workspaces to use. And the next important thing is we have permission claims. which means as a provider, these are the permissions which a consumer or the other workspace which is going to bind to my API is going to provide. So in very simple terms, the analogy which makes me clear in my head is you go to a Google Play Store or an Apple Play Store and say you want to download a particular app. Say you're downloading WhatsApp, and the next pop-up which comes in is do I have permissions to access the storage, or do I have permission to access the photos and stuff like that. It is the exact same thing. So what the provider is doing here is to be able to use the Cowboy API, you have to give me the permission to access your config maps. So now we'll go and create the API export.
Now you need to create it. You will not see it. That's right.
Okay.
I think there's some mix-up. Like you would not see it. It will come up later.
Okay. Thanks.
So API export is exposing the
Yeah, like
Kubernetes.
you take a schema. You can have like multiple schemas.
Okay. So in the API export, I'll just go over the important parts of the whole description. We have an identity that is for authorization. We'll go into detail later. But the next thing which we have is the permission claims, which says that this API needs permission to access all your config maps. And the third important thing is we have a specific individual URL to be able to access all the resources which are bound to this particular API, which means a provider can use this particular URL and access all the config maps or all the cowboys which are created in the individual workspaces which are bound to this API. So we'll go to its description later, but are we good till here in terms of creating an API export? Okay. Let's move on to the next one, which is basically changing roles and becoming a consumer. So as a consumer, I would like to use the Cowboy API. Now I'm going to create a consumer workspace, and I'm also going to create a sub workspace known as Wild West. And just to show you, in the API resources, I don't have any Cowboy APIs available. And now let's go and bind to the Cowboy API. We'll use the KCP bind command here. Where are we? Yeah, there we go. And I'll explain the bind command in a bit. What this command is saying is, as a consumer, I would like to bind to the API export, which is available in the workspace root providers Cowboys. Its name is Cowboys. And I would like to accept the permission claim for the config map which is being asked. Now, once the API binding is created, we see that, okay. Okay, let me do this. We'll see that the Cowboy API is now available. And now we can create an object through the Cowboy API which is available to us. So let's go and do the same. And let's create a Cowboy resource. There we go. So we saw that we have a consumer workspace. We saw that we created an API binding. We bound our workspace to a particular API, which is the Cowboy from a provider workspace. And then we have created an object named Bukaru Bill from that particular API which was available. Are we all good till here? Okay. Let's also quickly create another consumer just to show the whole concept of having another workspace, having another API binding, and then creating an API binding in that third workspace. So what I'm doing is I'm creating another workspace which is wild north, entering into it, and I'm creating an API export. I'm binding to an API export by creating an API binding, and then I have also created a cowboy resource in here. So the next thing which we would like to explore is let's quickly look at the tree. We have a provider, cowboy. We have a consumer. We have two sub workspaces in here. And we were able to create a cowboy API from the provider, bind to the provider and create it in the consumer workspace. One thing which you can also quickly look at by going into the consumer workspace is if you do a kubectl get CRD, you would not be able to see the CRD, which means that the object is not exactly available in your etcd. But you can create a resource, which we just did, the cowboy resource, and you can use it as per your wants. And that's what KCP does in the backend. The third thing which I would like to show is, if you would remember, we also had a workspace URL. Let's get into the provider and cowboys, and let's see this URL. And we were able, I had mentioned before that we can access all the cowboys are all the consumer objects which are created in the consumer workspaces and bound to the provider through this particular virtual workspace URL. So let's go and do that. Let me see the API resources that are bound to this particular provider API, and we see that we have config maps, we have cowboys, and then we have API binding. We can even go a step further and we see that from the provider workspace, we are able to see that there were two cowboy objects which were created in consumer workspace while north and while west. So this was a very brief overview about the whole workspace concept and how the APIs are isolated and how we can create an API export, bind to an API export without having the object in etcd. Are we all good till here? Did this all make sense? I hope so. Okay. One thing which you can do is also run this script to make sure that everything is good and going. And then we can move on to the third exercise.
So I'm conscious we're running a bit behind the schedule. And it was always the idea that we have more content than time. So how many people already finished this part and ready to move to database? Okay, we have quite a lot. So if you're not yet there, I would really like us to get through the database part because I think that's a nail of this tutorial. So we're going to go ahead now. But if you are still not yet there, please raise a hand. We're going to help you, and scripts are there to bootstrap. And if you need help, basically you can find us after workshop in a KCP-dev Kubernetes Slack. But for now, let's move further.
Yeah. I will take now for the next part. It is the part 03, dynamic providers. So what do we want to do here? We will explore some quite interesting concepts and try to put all these workspaces and stuff that we talked about in practice. And we are going to explain some software as a service scenarios. So let's imagine this. Let's imagine we have one cluster, or in this case, it's going to be a Kubernetes cluster that is going to use a service owner. We are going to run the Postgres databases there, and we are going to somehow give those databases to the consumers. And then we will have, on the KCP side, one service provider, which is going to, we will see how we connect with the service owners so that we connect the KCP on one side and the service owner on the other side, that is a Kubernetes cluster. And on the KCP side, we are also going to have one more workspace that's going to be used by service users, so user who is going to request the database for their application. So before we get started, we have a couple of things here that we need to run. So this is like setting up the environment. Let me see if we have, just a moment. Here it is. So we should already be set here. Just a moment, yeah. But I'm going to run it just to be on the safe side. And now the first thing that we are going to do is to create the kind cluster. And you can just copy this command to create that cluster. It might take a few minutes, but should be fairly quick in the GitHub workspaces. And let me quickly talk what are we going to do. So what are we going to do here is that once the kind cluster is ready, we are going to deploy the cloud-native PG, or Postgres SQL operator, that we are going to use for deploying the databases. Let me see if we have some progress on the kind side. So it should be up in a few seconds. And here it is. So I can do now kubectl version. And OK, this is not that one. We will need to do it like this. OK, now we can see the cluster. If we do something like get nodes, we can see the node. OK. So what are the next thing we are going to do? So we are going to create one API export that's basically going to provide the Postgres databases to other users in our KCP environment. It's going to be an empty API export. It's not going to refer to the API resource schema. We can, for a very quick moment, see it. And it's, as you can see, it's pretty much empty aside from the name. And we are going to create it. But before we do that, we are going to prepare one kubeconfig file that's going to be used by something that's called API sync agent. And we are going to see later on why are we doing that. But for now, let's do that. I made a mistake there. Let me just copy that again. OK, now it should be good. And we are first going to switch to the root provider's workspace. And then we are going to enter with that workspace. Actually, so we are switching to the root providers. And in that workspace, so I think it's something like this. OK, now we are seeing this. But if I switch, OK, now we don't have much time. But in root providers, we have the database. So if I would very quickly do this, you will see that now we have the database here. Now let me switch to it. OK, and now we are going to apply that relatively empty API export. And now we can see that it's ready. OK, now we have already seen it. Now we are going to create one more space that's going to be used by the consumer that we have mentioned. Just a quick check. Have you managed to get to this part yet? Quick hands up. OK, that's looking fine. Now I'm switching to the root consumer's workspace. At the moment, we have a couple of wild workspaces there, but we are going to create one for the Postgres. Sorry, that was the wrong one. This one. And now I'm going to create this for Postgres PG, and I'm going to bind to the API export that we created. So we are using the kubectl bind command, KCP bind command that we have seen. We are providing the reference to API export that we created in the provider's Postgres, provider's database workspace, and we are accepting some permission claims for secrets and namespaces. We will see how that works. OK, and now we need to somehow connect this all together. As you have seen, the API export is empty, and we need to somehow get sorry about this, the service provider and later on the service owner to get the resource that we want to expose, and which in our case is a database. And for that, we are going to use something that's called the API Sync Agent. It is a bit opinionated controller. Technically, you can write your own controller that's going to do all of this, and that's going to be adhere to your requirements. But we provide this one as a starting point that you can later on build. For example, you could use something like the multi-cluster runtime to build a multi-cluster aware controller. But we are going to use this one as it provides a very good starting point. We have installed it in the step 0, and for it, we created a kubeconfig earlier on. Now, the thing why we did that is that in the kubeconfig, in something that's called the current context, we define what it is via that way, defined what's the current workspace to be used. And when we provide it to the API Sync Agent, it's correctly going to know with what workspaces it needs to work. And finally, we are going to first switch to the provider cluster, so to the kind cluster that we have created, once again. And there, we are going to deploy the API Sync Agent. Actually, we are not going to deploy the API Sync Agent itself, but its CRD called Published Resources. We will later on run it manually. And now I am going to create a few published resources that we are going to see in a moment. OK, so what is the published resources thing that we created? It is a CRD that's provided with the API Sync Agent, and it's primarily used to connect the API export that we have in the provider workspace with the provider cluster that we have in our, that is basically our kind cluster. So we are here specifying in spec the resource that we want to provide. And this is the cluster in PostgreSQL CNPG IO group in the version v1. So this is the resource that we have in the kind cluster, in the provider cluster. Then we specify some rules, like how is the resources going to get synchronized, and we specify the related resources. So what is this going to do? Aside from the thing that the API Sync Agent will connect with the API export and provide the cluster resource in our KCP workspaces, Other thing is that it is going to cite the objects that we have, that we create as a clusters in the KCP, in the, our user workspaces, down to the provider clusters, where the Postgres instances will be actually run. And it is also going to synchronize the related resources. So for this Postgres, we need a secrets that contains the credentials. It is going to be taken from the user workspace, again, to the provider cluster. So it is pretty much providing binding from KCP to the Kubernetes cluster, which is used as a provider for the whatever we are providing. And it is also supposed to connect the APIs, so we get API that is in the provider cluster, we get it in the KCP workspaces. Okay, so this is all already created. API sync agent, this time we are going to run in our terminal. So API sync agent, we provide the namespace, we provide the API export reference, and then we provide the API sync agent kubeconfig that we created. Let me just check something. Okay, so here you will need just a very moment, please wait. Let me just check this kubeconfig.
So main point of this is, while he's checking, we have a providers cluster which owned by database team. Only database team has access to it. And we use KCP as a multiplexer, meaning everybody gets a workspace. You interact only with your workspace. And there is this connector multiplexer sync agent in between to enable this stuff. Like, not confuse that KCP and Kubernetes. KCP acts as an API gateway where it extends the existing multi-tenancy, basically, in a multiplexing way.
Okay, just a quick thing. So if you run into this problem, you can run this command down there. So with the kubeconfig that we created for API sync agent, you can provide it like this with environment variable with kubectl set the active workspace to root provider's database. So this command here, I will keep it for like 10 seconds. You can maybe take a picture or write it down somewhere. Okay. Was that okay? Quick hands up. Okay. So what do we have next? We have the API sync agent running. And now we need to start another terminal. And we are going to prepare this terminal by running what we have here in the box. And now we are going to switch to the consumer workspace, one that we created for PostgreSQL. And we are going to create first the database. And just a second. Well, let me see. Let me make sure I am in the correct workspace. Okay, that's definitely not supposed to happen. So it should be in the API bindings. It doesn't work.
what's happening. Did we... We're at running part, right?
Yeah. The API sync agent should be running there.
Oh, it should be running.
Yeah, here.
So fine. That's what you get for doing stuff live.
Did I switch to the correct with the when I switched the
That's, yeah, it's a polluted endpoint. So now you're gonna have to see a bit of live debugging. So every API export has a unique identity. So if your API export, like you start something to consuming it, somebody modifies identity. I think in this case, we just basically overrode the identity of export. Means that's not deployed.
did I deploy it at all?
Yeah, no.
Okay. Yeah.
Where was that? This guy.
Then we can just run the API sync agent again. What's going on? Good.
Is running? Yeah. So now diff that stuff.
Yeah, you need to run the API sync agent.
Yeah, I need to restart it.
Okay, so sorry about this. We don't forget to deploy the Postgres SQL operator like we did right now, but mistake happens, don't they? And let's see if it is going to work right now. Oops. So we are just checking, yeah, this looks okay, and then we can continue from creating the database. And looks like it has been created. We first created the cluster, and now we are going to create a database. And we are going to get the cluster. Okay, it is reporting back the status. So we are waiting it for to set up the cluster. Now if we would go back to the, let me see if I can do that in the meanwhile. Maybe it's going to get up. Cluster is at a healthy state. That's looking really good. And now let's try to see it in the service owner, how it looks like. So we are now making some assumption here, like that we can access all the cluster, including the service owner cluster. We can see here that we have the namespace for our Postgres instance, and we are seeing it running. So this is looking really good, and like we can even get the cluster in this namespace, or let's make it easy to get in the all namespaces, and then in the end, we are going to switch back again to the KCP setup. We are going to go to the consumer. We are going to get the databases, the clusters, and for the end, I think it was secrets. And we can see that everything has been created and properly synchronized between clusters. And for the very end, like what we can do, we will go to the provider cluster. Ideally, in this case, the provider should give you something like ingress or something like that to access the cluster. And let me see. Export qctl get what's a. Let me see if we get. Yeah, we have the namespace. Oh yeah, the namespace name. Thank you. Okay, and we very quick create the other terminal. Okay, let me do this way. This can be copied easily because of the. Yeah, we'll probably cut it short, but I can very quickly try to do something like this. And there we go. Okay. We are running out of time, so I will quickly write the Robert.
Yes, so unfortunately, it's taken a bit of time, and we are at the end of our session, but there is still quite some content left that we've missed. There is multi-cluster runtime. We had an exercise that you can do yourself from the same docs page that you have visited. Just follow the steps, the docs, and you can try it yourself. Those are, if you are interested, those two at the bottom. Tomorrow there is another talk by MJ and Nabarun, resource model beyond Kubernetes workloads. And for multi-cluster runtime, there is at 15 hours a talk about multi-cluster runtime. So if you are interested, give it a go. Do you have some closing words?
So, as always, we overshot with the content, so sorry for that. We understand that it's very complicated topic to deal with, so feel free to run through the content again if you want on your free time. You can find us on a Slack, KCP Dev in Kubernetes Slack. I would really want to say thanks to Robert, who didn't have a chance to do the keyboard clicking on here because his part was the most complicated and the last one. So for everybody who does the MCP part, have it in mind, it's basically the last component, controller runtime there. And if you have any questions about all this stuff, today in the afternoon we have a project booth in a project pavilion. Look for 5A or 5B, I think one of those, where we'll be hanging out. And if you have any questions, bring your laptops, same content. We're gonna answer you. And really thank you for everybody who stick to the end and complete it as much as we can. It's a big help, and if you have any feedback, again, Slack or just approach us. Cool. And for this, I think we even ran out of time for questions, so we're gonna stick around here for a few minutes if you have something. And thank you for all the co-presenters and presenters who've been on the stage.